Hello, this is Chemistry, the Central Science, 11th edition. We're in Chapter 2 on atoms, molecules, and ions. This is the end of the chapter. We are in question 57. Complete the table by filling in the formula for the ionic compound formed by each pairs of cations and anions, as shown in the first pair. So the positive is the cation. I see that as the positive is the T in cat. Okay, the positive would be the cat. Anion, an is negative. The N reminds me of negative. Cation always goes first. So, and the other thing is that they will always have a zero charge when they're finished. All ions are neutral electrically. So I've got 1K, okay, and 1Cl. It's a 1-to-1 relationship, so I don't need any subscripts. So it just becomes KCl, okay, potassium chloride. I'm going to do the same thing here. I'm going to have potassium, and in this case I've got a polyatomic ion. OH together is -1. That's hydroxide. So -1 and +1, they're balanced. So KOH is all you need, potassium hydroxide. Right? Now, I look here and I've got a +1 and a -2. So I'm going to go ahead and put this. And you don't put the charges ever. Carbonate, CO3 is -2. How many positive ones do I need to balance? Because they always balance to zero charge. So I have to have 2 Ks. Each one is +1. When I have 2 Ks, I have a +2. It balances with -2. So my formula will be K2CO3. All right. What about potassium phosphate? All right, so I have PO4. It's a -3. How many positive ones do I need to balance with a -3? I need 3. So this is potassium phosphate, K3PO4. All right, now I've got polyatomic ion, ammonium. It's the only positive polyatomic. And it is 1, and I'll look here, it's 1-to-1. So I'm just going to write them down, NH4, Cl. I don't need any subscripts because it's 1-to-1. 1-to-1 matches fine. Okay. Next one I have is 1-to-1, and they're both polyatomic ions. So this looks really complicated, but it's not bad. NH4 is +1. OH is -1. So this is ammonium hydroxide. Ammonium hydroxide. Likewise, this is a 2, so I'm going to write it. I wouldn't write it first, but I'm writing it first here because I'm going to ask how many ammoniums do I need to balance with a -2. Right? Ammonium is +1, so how many +1s do I need? I need 2 of them. Well, here's the weird. If you have more than one atom that together makes an ion, and you double it, I have to double the whole thing. I can't just double the last thing. I can't just double the hydrogen. I need to double all of it. So I'm going to have a parentheses. I'm going to put the NH4 inside. Okay, the whole ion is inside. Now, how many ions do I need? I need 2 of them. Okay, so it's NH4 subscript 2 CO3. That's ammonium carbonate. All right, so that's the first one that I would call hard. You can look at that again, study that. What about phosphate? PO4 is -3. See how I'm never writing the charges? The charges, because they cancel, the charges aren't written. PO4 is -3. How many ammoniums do I need if ammonium is +1? Well, I need 3 of them. So it's NH4. How many NH4s do I need? I need 3 NH4s because the whole thing is +1, and I need 3 +1s to balance. All right. What about magnesium and chloride? Magnesium is 2. Chlorine is only 1, so I need 2 of those to balance. I need 2 negatives to balance with a positive, or with +2. Likewise, Mg is +2. How many hydroxides do I need? Since it's OH, I need 2 of those because they're -1. I need 2 negatives to balance with the 2 positives. What about this one? I've got magnesium, which is 2, and carbonate, which is 2. You see, I don't need anything at all because 2 and 2 is same as 1 and 1. It cancels, completely cancels the charge. Here's where it gets weird. This is the real hard one. PO4 is 3 and magnesium is 2. What do I do? Okay, I'm not done yet. So I'm going to write up here, and for just in my head, I'm going to say that that is 3 negative. And this is magnesium is 2 positive. So I need to somehow make them balance. I need all the positives to be the same number as the negatives. Well, this is back to 4th grade, 5th grade, when everything, you had to do the multiples and the common multiples and find denominators and all of that awful stuff. So 2 times what is 6? 2 times 3 is 6. 3 times 2 is 6. Do you see what I've just done? I've turned both of these. 2 times 3 is 6. 6 positives. 3 times 2 is 6 negatives. Now 6 positives, 6 negatives cancel. But what have I done? I have made a subscript here of 3 and a subscript here of 2. Now look why I brought you down. The one on the far right is the same as the subscript on the left, and this one's the same as the subscript on the right. Let me do it again. Mg2 plus, PO4 3 minus. This becomes 3. This becomes 2. Okay. Here's a problem. It's not just the oxygen that becomes 2. It's the entire phosphate. All of it is doubled. See, we don't have a problem here with magnesium because that's just one element. But this -3 is not just the oxygen. It's the phosphorus and the oxygen together as one thing. And so if I'm doubling that thing, all of it has to be doubled. And so I need parentheses. So that means this is going to be Mg3 subscript PO4 2. Okay. What about iron? Okay, this is iron 3, which is positive 3. How many chlorides do I need? I need 3. Okay. Here's iron 3. How many hydroxides do I need? You see that I have to do the parentheses. I need 3. All right, what about iron and carbonate? Well, it's the same thing. This is 2. This is 3. So, no, I'm sorry. This is 3. Got it backwards. This is 3. This is 2. That means this becomes 2. And then I have to have parentheses. And that becomes 3. All right. So this was very similar to that one. Okay, where you had to do the switch. Okay. The last one is 3 and 3. No big deal. This is iron phosphate FePO4. Okay. Hope you're learning.